Hey everybody, this is Mrs. Snook with section 8.3, Geometric Sequences and Series. Our objectives today are to write and find the nth term of geometric series. We're also going to find nth partial sums of geometric sequences, just like we did with arithmetic sequences. And we're going to find infinite sums of geometric series. And we can also use the same idea of the geometric sequences to solve and model real-life problems. So here we go. Our first example is just examples of what geometric sequences are in the first place. So number one, the sequence whose nth term is 2 to the n, that's geometric. If you think back to arithmetic sequences, you added a common term each time. Common difference, we called it. Now with geometric, what's happening there is instead of a common difference, we have a common ratio. And this means that to get your next term, you always take the term that you're on and multiply it by that ratio. So take a look at this. We have 2, 4, 8, 16. Take 2, multiply by 2, you get 4. Take that 4, multiply by 2, you get 8. Take the 8, multiply by 2, you get 16. So between each one, we have a times 2. And that's how you can tell it's a geometric sequence. You have a times 2. Now take a look here. We've got 12, 36, 108, 324. And this one, the nth term is 4 times 3 to the end. So right there is your common ratio. This also works very similar to an exponential function. If you remember with exponentials, you would have a to the 0 times b to the x. And then, so instead of using x, we're using n. And this will be y of x, or just y. So you would plug in x and then generate your values for your exponential function. Works the same way when it's geometric. Look, right there, that's a of 0. Now when we start writing these sequences, we start at n equals 1. So you put in a 1 for n, you get 3 times 4 is 12. That's where this one's coming from. And then you do a times 3 between each one. Times 3, times 3, times 3. If you wanted to get the term before the 12, if you wanted to get the 0th term, then what you do is you plug in a 0 here for n, and then you would have 4. All right, let's take a look at another one. This one is the sequence whose nth term we have negative 1/3 to the n. So check this out. That's our common ratio is negative 1/3, which means that to get the next term, you always multiply by negative 1/3. So start with 1, n equals 1, you get negative 1/3. And then multiply by negative 1/3, you have positive 1/9. Notice how the sign changed? And then multiply by negative 1/3 again, you have a negative 127, again sign change. And notice how each denominator is getting multiplied by 3. Sign change, and then multiply by 1/3, so you get positive 1 over 81. All right, now let's take a look at finding the terms of a geometric sequence. We're going to write the first 5 terms of the sequence whose first term is 3, so a sub 1 is going to equal 3, and whose common ratio is 2. So I'm going to multiply each one by 2. So I have 3 multiplied by 2, I get 6. Multiplied by 2, I get 12. Times 2, I get 24. And times 2, I get 48. So just do a times 2 between each one. All right, now we're going to find the 15th term of the geometric sequence whose first term is 20 and whose common ratio is 1.05. So I know my first term is 20. So a sub n is going to equal 20. And then I'm going to multiply this by 1.05. Now, do I go to the n? If I do it to the n, then my first term wouldn't be 20. Because what I would get is, if I do it like this, then a sub 1 is going to be 20 times 1.05 to the 1, which is going to give you, if you do that, you get 21. So we can't just do 20 times 1.05 to the first, because we're getting a different number here. We wanted 20 to be our first number. So what I'm going to have to do is make an adjustment, and this is going to be 20 times 1.05 to the n minus 1. Now let's see if that works. So a sub 1 is going to be 20 times 1.05. n minus 1 is 0. That goes to 1, so 20. There's a nice little formula that you can use for figuring out whichever term of a geometric sequence that you want. And what that formula is a sub n equals your first term, which is a sub 1. We're going to multiply it by the common ratio, but we're going to do n minus 1. If you do it that way, then every time you'll get the correct numbers for your terms. All right, so now we're going to find a term of the geometric sequence. We want the formula for the nth term of the following geometric sequence. So we have 5, 15, 45. So let's figure out what the common ratio is going to be. So my common ratio R is going to be, I just need 2 consecutive terms. So I'm going to do 15 over 5, and I get a 3. So what that means is 5 times 3 is 15. 15 times 3 is 45. So my next term would be 45 times 3. And that gives me 135. And you could just keep going like that, just keep multiplying terms by 3. Much, much, much easier is to use the formula that we looked at last time. So a sub n equals a sub 1 times r to the n minus 1. And I want to go ahead, I'm going to put in the nth term. I'm going to put in a sub n equals, put your a sub 1 right here, that's the 5. Common ratio is the 3 times 3 to the n minus 1. And that's going to be your formula for the nth term. Then it says, what is the 9th term of the sequence? I'm going to put in a 9. So a sub 9 is going to equal 5 to the 3 times 9 minus 1, which is 5 times 3 to the 8th. Now just grab your calculators and punch in 5 times 3 to the 8th. And I'm going to do that on mine. And I get 32,805. So a sub 9 is 32,805. In our next example, this one's a little bit different. We're told the 4th term of a geometric sequence is 125. So a sub 4 equals 125. And the 10th term, this is a sub 10 is going to equal 125 over 64. And so now we're trying to find the 14th term of the sequence. And so first thing we need to do is figure out r. Because remember, our formula is a sub n equals a sub 1 times r to the n minus 1. This means I need r and a sub 1. So first, let's get r. Now, I know that a sub 10 is going to be a sub 4 times r to get a sub 5, another r to get a sub 6, a sub 7, a sub 8, a sub 9, a sub 10. So this is going to be a to the 4th times 1, 2, 3, r to the 6th. Now to solve for r, I know that a sub 10 equals a sub 4 times r to the 6th. So then a sub 10 over a sub 4 is going to be r to the 6th. So I'm just going to plug in what I know, and that equals 125 over 64. And that's a sub 10, and then we're going to divide by another 125 because that's a sub 4. And this is going to give us 1 over 64 equals r to the 6th. So now all I have to do is take the 6th root. So I'm going to get my calculator. I'm going to show you how to do this. I need the 6th root, so I'm going to go to math. I'm going to come, oops, hit the wrong one, math. I'm going to come down to number 5, where it lets me say what root I want. I'm put the 6th root of 1 over 64. And that gives me 0.5, which we know in fraction terms is 1/2. So then r equals 1/2. All right. Now I need to get the first term, a sub 1. Well, I know that a sub 1 times r is a sub 2. So I have my r here. So a sub 2 is going to be a sub 1 times r, right? And then a sub 3 is going to be a sub 1 times r. And then a sub 4 is going to be a sub 1 times r times r times r. So I am just going to take a sub 4, which is 125. Sorry, a sub 1. You're coming over here now. A sub 4 is going to be a sub 1 times r cubed. So then a sub 1 is going to be a sub 4 divided by r cubed. And I know r is 1/2. So I'm going to do 125. I'm going to divide it by 1/2 cubed. So now a sub 1 is going to equal, I'm just going to go ahead and do this on the calculator. So I'm going to do 125, and I'm going to divide it by 0.5, and I need to cube that. Cube. And that gives me 1,000. So now I've got a sub 1, I've got r, and I'm ready to write my equation. I'm going to come over here. So a sub n is going to be 1,000 times 1/2 to the n minus 1. The last thing it asks for is the 14th term, so I'm going to plug in 14. So a sub 14 is going to be 1,000 times 1/2 to the 13. So I get my calculator, 1,000 times 0.5, raise that to the 13, and I get 0.122. I get this big decimal. Let's see if it's any easier in fraction form. So I get 125 over, looks like 125 over 1,034. 1,024, so it's 125 over 1,024. And there you have it. All right, now the next thing we're going to do is we're going to start finding sums. This is just like with arithmetic form, we were able to, arithmetic sequences, we were able to predict terms, write expressions for the terms. Now we're going to do the sums. We're going to start adding them together. And there's a nice little formula that we can use. First thing is, let's look at it if we don't use a formula. So this is going to equal 4 times 0.3 to the 1, which looks like this. So 4 times 0.3 to the 1 plus 4 times 0.3 to the 2 plus 4 times 0.3 to the 3, and we just keep going until we get 0.3 to the 12. That's option 1. Okay, sit down and work that all out, each one on your calculator, then add them all up. Or, much easier is to use the formula, and here's our formula. It's this, the sum of I equals 1 to the n of a sub 1 r to the I minus 1. And that's going to equal a sub 1 times 1 minus r to the n over 1 minus r. So if I am doing a sequence, it's a geometric sequence. Here's a sub 1. I'm counting from 1 through n. So I'm going to do r to the whatever count we're on. I'm using I for that, I minus 1. So 1 minus 1, and then when it's 2, it's going to be r to the 2 minus 1, r to the 3 minus 1, and so forth. That generates this right here. And then you just plug into the formula to get your answer. I know a sub 1 is 4. 1 minus, what's r? Well, r is 0.3 right there. So 0.3 to the n. That's n is 12. Over 1 minus 0.3. And then our answer is approximately 1.71. All right. Now the next thing we're going to do is we're going to find the sum of a geometric series, but this time it's infinite. So notice we're going up to infinity. We're not going to stop at a specific number. And we have another formula for that one. This one's actually easier to use than the last formula. I'm going to write it here for you. So when you're doing an infinite series, you're just going to do a sub 1 over 1 minus r. So for an infinite series, when you're indexing from 0 to infinity, notice we're starting at 0 instead of 1. That's a little bit different, but we're going to start at 0 instead of 1. And we're going to do a sub I times r to the I. Notice again, because we're starting at 0, I'm not going to do I minus 1. I'm just going to do I. And that's going to equal, check this out, a sub 1 over 1 minus r. That's all you got to do. Here's your a sub 1. And then, this one is going to be your r. Go. We're going to do 4 over 1 minus 0.6. And get your calculator. And that is going to equal 10. So that's how we find that sum. Now look at this one. This is a different example. So think of this as A and B. These two are not related. We've got 3, 0.3, 0.03, 0.0003. And what do we need? We need the first term right there, and we need R. So R is going to be 0.3 over 3. I just take my first two terms, and I get 1 over 10. So now my sum is going to be, that is going to equal our first term, 3 over 1 minus 1 over 10. Put that on my calculator, and we're going to get approximately 3.333, and it's actually going to keep going. And that's it for today's video. Thank you for watching.